Okay, so let's talk through the steps for solving or for adding and subtracting fractions in using these two. All right, step one is to factor completely. Hey, Jack, would you mind shutting, or Jordy, would you mind shutting that door for me, please? Thank you. All right, so step one is to completely factor. All right, so in this first example, it's already written as factor, so you can jump to the next step. Thank you. Okay, step two is to write the entire expression as a single fraction. Okay, and the way that you do this is you're going to find the LCD. Okay, so when we write it as a single fraction, you need to include every factor of each denominator in this fraction. So we have an x plus h factor, and we need a factor of x. So there's our two LCD factors, a binomial and a monomial factor. Okay, once you find your LCD factor, what you're then going to do is you're going to multiply each fraction's numerator by the LCD factors that are missing from its denominator. So when we come back here, okay, and we look at this numerator of our first fraction, which is a 1, we're going to multiply that by whatever LCD factor is missing from this first fraction's denominator. It has the binomial, it's missing the monomial x. Okay? Then we're going to take our next fraction's numerator, so minus 1 times the LCD factor that's missing from its denominator. This one has the monomial factor x, it's missing the binomial, so we write that down. Okay, so once you write this as a single fraction, your next step is going to be to simplify. Okay, and simplifying begins with the numerator. Okay, so we're going to simplify our numerator. We have x, distribute our negative, minus x minus h. The x's cancel, so we're left with a negative h over x times x plus h. Okay? And then it extends, part of simplifying is to reduce your fraction. Okay, so if this can be factored any further, we would do that. If we need to identify any domain restrictions in that process, we would do that as well. No factors got canceled from the denominator, so there's no domain restrictions other than what's apparent in that simplified form. All right, let's take a look at this second example, kind of going through these same steps. Okay? So in this second example, we do need to factor. So the first fraction is just fine. The second fraction, also fine. But this third one, the numerator can be factored. There's a common factor of negative x in each of those terms. And the reason I chose a negative was, remember when you write your factors, or part of the factored form is to get all your factors to have or to be written in standard form with a positive leading coefficient. So if we were to reorganize this negative x squared plus 4, we could take out a negative x, leaving a positive x and a negative 4. And then in our denominator, we have this difference of squares. So this will factor into the sum of terms times the difference of those same terms. Okay, so this is our entire process of factoring. And now it turns out when you subtract a negative, subtracting is equivalent to adding the opposite, which is why when you take two negatives, they can turn into a positive. So you can turn that into a positive, and it simplifies it even further. Okay, so now we're going to write this as a single fraction. So as we go through to write that, we just move fraction by fraction. We need a factor of x minus 1 in our denominator. We need a factor of x plus 1. It wasn't there, so we have to include it. We're going to look at our final fraction. We need a factor of x plus 1, which we already have, a factor of x minus 1, which we already have. So you don't need to repeat them unless there are multiple occurrences of that particular factor in the same denominator. Okay, so here's our LCD. So now we're going to go back in and multiply the numerator of each fraction by whatever LCD factors are missing from their denominators. So take the 2, the first fraction's numerator. Which LCD factor is missing from this denominator? X plus 1. Plus the next fraction's numerator 3 times what's the missing LCD factor here? X minus 1. And then finally plus x times the quantity x minus 4 times what's the missing LCD factor in this denominator? It's not missing anything. So you can put a 1 if you want. There's no reason to put anything. It just doesn't require anything else. It had all the LCD factors. Okay, so our final step here is to simplify. I'm just going to simplify below this green line. So I have my 2x, my plus 2, distribute my 3. I have a 3x minus 3, distribute my x. I have an x squared minus 4x. So when you simplify this, we get a net of x squared plus 1x minus 1. Okay, so here's our numerator. Now, that's the first part of simplifying. The second part is to reduce this rational form. So if this can be factored any further, I want to write the factors in this simplified form. So are there any factors of -1 whose sum is positive 1? No. Okay, so you can't factor that expression any further, so we'll write it as the trinomial form. And then the denominator stays in the factored form that it was. And did we cancel any factors from the denominator throughout this whole process? No. So we don't need to include any other restrictions. That's all we need to do.